In this video, I'm going to be showing you how to write a quadratic in vertex form from using a point and a vertex. So we're going to be writing it in vertex form using a point and vertex. So the first thing we need to do is you're going to be given a graph, right? Or you could be given ordered pairs that represent the vertex and a point, but more than likely you're going to be given a graph. And so the first thing we have to do is we have to find our vertex and we have to label it, and we have to find a single point and label it. So I'm going to start with the vertex. If you didn't know, if we go ahead and we go over to this graph, your vertex is simply the highest or lowest point of your parabola. In this case, it's the lowest point. So that is going to be our vertex. And when I write an ordered pair for that location, in this case, it actually just happens to be 0, 0. So I'm going to write 0, 0. Now in some cases, right, it could be somewhere else. It could be over here at 2, 0. It could be up here somewhere. But just know that the vertex is either the lowest or highest point of your graph. So I'm going to just write a note over here. Vertex, highest or lowest point on graph when your parent function is a parabola, right? Now, so we got the vertex label. We need to label one point. I'm going to go ahead and stick with the positive numbers. I like positive numbers. This going over from origin is 1, and then I go up 1, 2. In other words, that point lines up with 1, comma 2. That's my x value. That's my y value. When I say x, right, we're talking about the x-axis that runs left and right. When I say y, that's how far up and down it goes, the y-axis. So now I've got an ordered pair that represents a point on my parabola, and I have the vertex, right, the location, which happens to represent the lowest value on this particular graph. That's my minimum. And I'm going to use that in the equation for vertex form, which, if you didn't know, it is f of x is equal to a times x minus h squared plus k. Now, we are going to be substituting some values here, but before we start substituting them, I want to go ahead and I want to label some things on my vertex and on my ordered pair, which represents the point on my graph. Now, for the vertex, I'm going to label the x value h, and I'm going to label my y value k. And in this equation here, just so you know, I'm going to end up substituting them for h and k. So that's why I labeled them. Now this has to be the vertex, not the point. The vertex gets labeled h and k. Then I'm going to go ahead and label the ordered pair, which is just a point, any point on my graph. I could have used the one on the left, or I could use any point that's on the right. We don't want to use the vertex, but any point other than the vertex. And I'm going to label that one just regular x and y. So now that I got these points labeled, I'm going to go ahead and start substituting. Now, a couple things you need to remember is that with this x and y, first of all, it's going to be this x right here. And when we say y, y is the same thing as f of x. So y is going to be replacing this f of x right here. So let's go ahead and rewrite this real quick with these values in it. Now, instead of f of x, I'm going to go ahead and put a set of parentheses, and I'm going to put my y value of 2. So this way you can see everywhere where I'm putting the values. And this is going to be equal to a times my x value, so I'm going to put parentheses. My x value happens to be positive 1. And then it's going to be minus my h value. Okay, my h value happens to be 0 in this case. Close parentheses squared. And then notice it says plus k. So in this case, my k value is 0. So I'm going to go ahead and put plus my k value of 0. Now the zeros don't make a whole lot of difference, so I'm going to basically do two different problems. One that doesn't have a vertex at 0, 0, so you can see the difference. But you substitute the values in. Right here we have our y value of 2, we have our x value of 1, we have our h value of 0, and we have our k value of 0. And now I'm going to go ahead and I'm going to solve this real quick for a. And this is your first step. So I'm going to write right here, step 1. Now if I do the math on here, right, I'm going to bring down, I got 2 is equal to a, parenthesis, and I'm going to go ahead and subtract this. This is 1 minus 0, and that just leaves me with 1 squared, and then we have plus 0, right? And that doesn't change anything, so plus 0. Now you could just put this all in a calculator, like right here, this little piece, to see what it is, but we're going to do this by hand. So I'm going to rewrite this again. I'm going to continue the process. So I got 2 is equal to, and 1 squared is just 1. So that's like basically saying 1 times a. So I'm going to say, actually, you know what? I'll write it out just so you can see it. A 1 squared, if I put that in a calculator, is just 1. And plus 0 doesn't change anything, so I'm just going to leave the plus 0 off. So what I end up with, if I multiply 1 and a, it's just going to give me a is equal to 2. Now this is the first step. Once we located our vertex and our point, we substituted the values, and that's because we need to know what a is in the formula. Because when we rewrite this formula up here, with the h and k added to it from our vertex, we need to make sure that we put the right number in front of the parenthesis. And a lot of times it's going to be 1, but sometimes it's going to be like this one. You're going to have a 2. So now I'm going to go ahead and go to the next step. So I'm going to write step 2 on there. So step 2 of solving this is I'm going to go ahead and rewrite this formula once again. So I have f of x is equal to a times x minus h squared plus k. And now we're going to just simply substitute our values for a, h, and k. We found a, and h and k, we had found it earlier when we looked at the graph. So let's go ahead and substitute those values real quick. And I'm going to move this up just a little bit. So this is actually going to be f of x is equal to my a value of 2. So instead of an a, I'm just going to write a 2 in its place, times x, and it's going to be minus, and my h value happens to be 0 in this case, so I'm going to write a 0 in place of h, squared, and then it's plus k. My k value also happens to be 0. And if I wanted to make this look a little nicer, I could say this is really just f of x is equal to 2 times x minus 0 squared. Right? Leaving a plus 0 on there doesn't change anything, but this is the equation in vertex form, which you see right here. Right? But if it were written like this is correct as well, because typically in mathematics, if we're just adding a 0, we just leave it off. And so, but this is it in vertex form. So let's do one that doesn't sit at origin for its minimal point or maximum point. So you can see one that varies a little bit. So we have another problem here. Notice our vertex is clearly not on origin, and we have a couple points on our graph for us. So let's go ahead and take a look. The first thing I want to do is I'm going to choose a point. I'm going to choose this point right here, and I'm going to label it real quick. That point, its location, the x value is 1, 2. So it goes over to negative 2. That's my x value. And then the y value it lines up with looks like 1, 2. So a positive 2. That's my y value. So that's my first point that I chose. It's at negative 2, positive 2. Now, I'm going to go ahead and label my vertex. My vertex is right here. That's my vertex. And I'm going to need the ordered pair for that vertex as well. And it looks like if I find the vertex, I go over 1, 2, 3, 4. And then to get down to it, I got to go down 1, 2. So it looks like negative 4. And then the y value is negative 2. And I'll just draw some dots to it so you can see that it lines up with negative 4, negative 2. So now that I have this here, I have my vertex labeled, and I'm going to label that H and K. So I have everything I need. I have my H value, my K value, my X value, and my Y value. This is my vertex, and this is simply just a point on my graph. You can always use any point. That's a good point. That just happened to be the one that I chose, was the one on the right. So I've got this done, and now I want to go ahead and go to that step 1 of solving, now that I have the information I need to solve. And I'm going to go ahead and write my formula in vertex form. So it's f of x is equal to a times x minus h squared plus k. Now what I want to do is I'm going to replace the f of x with my y value, which in this case happens to be 2. So as I'm substituting them, I'm going to write them all in red. And then that's going to be equal to a times my x value, and that's going to be negative 2 on this one, minus my h value, and that's going to be negative 4, and then close parentheses, squared, and then plus k, and my k value is negative 2. So I'm going to go ahead and put plus negative 2, and that's this value from k right here. So once again, you can see that I used the vertex h and k points to replace h and k. I used my point x and y values to replace my x and y. And now we're just going to solve for a. So I'm going to go ahead, we're going to do some, now here, notice right, we got a lot of negative signs going on. So this is a good problem. We're going to use some distributive property. This one has no negative sign in front of the parentheses, so I can just drop the parentheses, because positive 1 times 2 is just 2. And this is equal to a times, but before I go any further, I'm going to go ahead and start distributing. Now I do have a negative sign here, so I want to take that negative sign and distribute it. When I say distribute it, imagine there is an invisible 1 in front of every parenthesis. So there's an invisible 1 right here, and this negative sign goes with it. So this is like saying negative 1 times negative 4. And if you were to put that in a calculator, negative 1 times negative 4, it's going to turn it into a positive 4. So here, I'm just going to bring down the negative 2 outside of the parenthesis because there's no negative sign in front of the parenthesis. The reason I say that I'm making a point that there's no negative sign is we just have a positive 1 being multiplied to negative 2. So it simply stays negative 2. But here we have a negative 1 being multiplied to a negative 4. And again, a negative times a negative makes it a positive. So that turns into positive 4. So we brought this down. After we distribute it, this is squared. And then now we have a positive being multiplied to a negative. Now in this case, right, the negative always wins, as I like to say, because we have positive 1 being multiplied to negative 2. That is simply going to give me negative 2. So we're going to continue doing the math. I'm just doing it in little tedious steps so you can see everything that I'm doing. So I got 2 is equal to a parenthesis, and if I do negative 2 plus 4 and I were to put that in my calculator, it's going to give me a positive 2. And that's going to be squared. Just bring this down, minus 2. And now we want to figure out what is 2 squared. And 2 squared is the same thing as 2 times 2, which simply gives me 4. So I'm just still bringing everything down. Alright, now this one's going to need a little bit more work, right? We've brought everything down. And what I need to do is I have a times 4. Now typically if you were doing algebra, we would always put the coefficient in front. In other words, we would write this as actually 4a. It's the same thing as multiplying a times 4. We just always put the number that's being multiplied to it in front. And so if I rewrite it like this, it's probably going to look a lot more familiar to you. And if I want to solve this, this really is a basic two-step equation. I just want to add 2 to both sides. That gets rid of 2 on this side, add 2 over here, and that gives me 4. And this is equal to, realize that was in the way. This is going to be equal to 4a. So we're almost done. Now if you're looking at it going, Mr. H, how did you know to add 2 to this side? Well, we were subtracting 2, right? And if we want to move that term, negative 2, over to the left side of the equation, I have to do the inverse operation, which is add 2. So this became 0, so it canceled out. Now the last thing we want to do is we want to get rid of this coefficient of 4 that's in front of the a, that 4 that's being multiplied. So I am going to divide by 4 on both sides. And 4 going to 4 one time. I'm going to move this up just a little bit. And this is simply a is equal to 1. Now that was a whole lot of work just to figure out that our answer was 1. Again, most of the time your answer is going to be 1 for this when you do the work. But sometimes it could be a different number, so you always got to check it. So a is 1. So now it's great. I have my a value, which is 1. I already know that my vertex is right here, and my h value is negative 4. My k value is negative 2. I'm ready for step 2 to go ahead and write the final equation. So right here, I'm going to write step 2. I'm running out of room, so I'm going to do it right here. So I'm now going to go ahead and write f of x is equal to, and it's going to be a times x minus h squared plus k. And at this point, we're just substituting numbers. We're going to substitute a for a, right? That one value for the a. And we're going to substitute our h with a negative 4 and substitute our k with a negative 2. So let's go ahead and do that. So for a, I'm just going to put a 1. So this is actually equal to 1 times x minus, now my h value, got to be careful with this one because it has that negative sign, negative 4, close parenthesis, squared, and then plus my k value. Once again, that k value is negative 2. I'm going to put it in parentheses. So you can see that all I did was replace the a with a 1, the h with a negative 4, and the k with a negative 2. So I'm going to move this up just a little bit more. We're almost finished. Now we got some distributive property to do before we write our final answer. I do need to distribute this negative sign to this negative 4. And remember, a negative times a negative makes it a positive. So that becomes a positive 4. And then I'm just going to bring down my x and close it, bring down my square symbol. Once again, a positive times a negative. The negative is going to win, so that just becomes minus 2. And this 1, we could write it in front of the parenthesis, but we really don't have to, because anytime there's always an invisible 1 in front of every parenthesis. So we can simply leave it off. And my final answer looks just like this right here. So now that I've taken a point and the vertex from the graph and I substitute it in order to find out what a was, and once I found a, I then substituted a, and then substituted my vertex's value for h and my vertex's value for k. And I went ahead and distributed this negative sign, distributed that positive sign, and I now have my final answer, which is f of x is equal to x plus 4 squared minus 2. And that's all there is to it. So that's 2 examples. Hopefully this helps you. And go ahead and use this process on all the problems that you have that have a graph in order to find the equation in vertex form.